In this video, we're continuing our discussion of pressure and what things affect the pressure of a fluid. So we had talked earlier in the last video that pressure increases as you go deeper in a fluid. Some examples of this is when you go higher in an airplane, the pressure is actually less when you're up in the airplane because you're higher in the air. So in the airplane, there is less pressure acting on your body from the air. However, remember, you still have that pressure on the inside pushing out. And therefore, there's an imbalance in the pressure. There's still all this pressure inside you, but there's less pressure outside. And this is the reason why your ears pop. Your ears pop to make the pressure on the inside of your body the same as the pressure on the outside of your body. Now, one of the ways to make your ears pop is to chew. And so that's why the airlines used to give you things like peanuts to chew on, or you might take some gum nowadays when you go on an airplane, and that chewing helps your ears pop. You also feel greater pressure on you when you go deeper in a fluid like water here. So when we're deep in a fluid, then we have a large amount of pressure on our bodies. And so this can create a condition known as the bends, which allows more nitrogen to get in your bloodstream. And if we rise to the surface too quickly, well, then the nitrogen comes out of our blood, and that can create a very uncomfortable feeling because that nitrogen, which is a gas, will collect at your joints. And that's going to create a lot of discomfort at your joints. And that's why divers have to slowly rise to the surface. If they rise too fast, it allows those nitrogen bubbles to collect at their joints and their blood, and it could possibly burst a blood vessel if you do so too quickly. Also, if you ever go diving, scuba diving, you have to sign a waiver that you agree not to fly in an airplane within so many hours. And the reason is because if you change in pressure too much, that can be very dangerous for your body. What I'd like you to do to see how well you understand this is, I want you to write your answer to this question. How do you think the pressure at 1 meter below the water level in our pool compares to the pressure 1 meter below the water in the ocean? So if you go to the school pool and you go 1 meter below the water level, or if you go in the ocean and you go 1 meter below the water level, how do you think those two compare to each other? So I'd like you to pause the video, answer that question, and then when you're done, unpause and see how well you did. Welcome back. Hopefully you got a chance to write your answer here. And hopefully you wrote something similar to this. That is that the pressures are going to be the same at both locations. It has nothing to do with the size of the water, how much volume there is. It only has to do with the depth. So because they're both at 1 meter deep, they will have the same amount of pressure, whether you go 1 meter in the swimming pool or 1 meter below in the ocean. Now we're going to write down this formula here for the pressure as a function of depth. In this formula, P refers to the pressure at the bottom. P sub 0 refers to the pressure at the top, or zero depth. This funny looking symbol here is actually the Greek letter rho, and that represents the density. G is the gravitational acceleration, which is 9.8 meters per second squared, and that's always that number. And then H is our depth, measured in meters. Let's go through a problem involving this formula. It says that a fish swims in a freshwater lake at a depth of 10 meters. Assuming that the atmospheric pressure at the lake's surface is 101,300 pascals, what is the pressure on the fish? And the hint here is that the density of water is 1,000 kilograms. So what this is referring to here is that the water's surface, we have a pressure of 101,300 pascals. We want to know the pressure on the fish down here if we are 10 meters deep. So what I'd like you to do is I'd like you to solve this, see how well you do, solve it on your own, and then when you're done solving this, I want you to see how well you did. So pause the video now and work on this problem, and when you're done, unpause the video and see how you did. All right, welcome back. You should have these values. We are finding the pressure at the bottom, that is our letter P. The pressure at the top, which is P sub 0, is 101,300 pascals. Our density is 1,000 kilograms per cubic meter. And the gravitational acceleration is always 9.8 meters per second squared. We are at a depth or height of 1 meter. Our formula will be the pressure at the bottom equals the pressure at the top plus the density times 9.8 times the depth. We place those numbers into our formula, and we get a pressure of 199,300 pascals. That is almost double what the pressure is at the top. That's only going 10 meters deep. That is about 3 or 4 stories tall. So if we go down about 3 or 4 stories, we go about 30 feet down, we are going to get about double the pressure of what we feel when we're standing on the dock. So it doesn't take a lot to increase the pressure when you go deep into the water. What I'd like you to do here, you're going to answer these 2 questions. There's 2 questions at the end. I want you to try your answer at these and pause the video and write them down, then unpause the video and see how you did. In the first question says a woman wearing snowshoes stands safely in the snow, but if she removes her shoes, she quickly begins to sink. I want you to explain this phenomenon using the words pressure and area. So again, pause the video, write your answer. When you're ready, unpause, and see how your answer compares to what we've written in the past. Okay, welcome back. Here's some answers from some students in years gone by. So hopefully your answers are something similar to one of these. First person said, with the snowshoes on, the lady has more surface area. The more surface area, the less the pressure. The second person said, snowshoes increase her surface area touching the ground, decreasing the pressure per square inch. It's the same concept as the bed of nails. Third person said the snowshoes have a greater area than her feet alone, so the pressure is lessened when she wears the snowshoes. Without the shoes, the pressure is greater and thus she sinks. And the last person wrote, how is it that someone wearing snowshoes doesn't fall in the snow with them on? The snowshoes increase the surface area of the person, distributing the weight over a larger area on the snow. And the second question, again, I want you to pause the video and answer this, and then when you're done answering it, unpause and see how you did. The question is, which dam must be stronger, one that holds back 100,000 cubic meters of water at 10 meters deep, or one that holds back 1,000 cubic meters of water at 20 meters deep? So again, pause the video, answer your question, and when you're done, I want you to unpause the video and see how you did. Okay, welcome back. Let's see how your answers compare to some of the students that have answered this in years past. So here's some answers from students a few years ago. One student answered the smaller one because the deeper you go, the more the pressure is. Therefore, the amount may be smaller, but the pressure is larger. Second person said 20 meters deep because the further it moves from 0 meters, it gets more pressure. In other words, it's stronger. The last person says the lower one because the water gets a bigger amount of pressure, the lower the hole is. So hopefully you wrote something similar to these. If not, make sure you write either one of these answers down or something similar to them.